All right, the big one on in chapter 8, the first part of trigonometry. All the vocabulary we will be using for the very first time: trigonometry, trigonometric ratio, sine, cosine, tangent, and the inverse of sine, cosine, and tangent. Okay, this is where we're going to prove our shadows and how accurate were you when you did your shadows a couple of weeks ago. And carrying on with chapter 7, as you can see, the first part is trigonometric ratios. Okay, here's a bit of information about trigonometry. It means triangle, measure of triangles and distances, etc. But everything will be put in a ratio. So if we go back to chapter 7, when we were doing ratios and proportions, it was getting you prepared to do trigonometry. And here's the 3 different ratios that you're going to use: sine, cos, and tan. The sine of an angle, the cosine of an angle, the tangent of an angle. And what can we use to remember it? You will hear the word Sohcahtoa, Coshchahtoa. Sine equals opposite over hypotenuse, that's this one. Cosine, adjacent over the hypotenuse. And then finally the tangent opposite over the adjacent, Sohcahtoa. You're going to hear it, like I said, so many times over the next couple of, well, certainly the next few chapters. And here's putting them into practice. Okay, first of all, obviously, as we've discussed, you need to target the angle, quote the formula, replace, so substitute and come up with an answer, and it needs to be correct to whatever degree of measurement that you are asked for in the question. So make sure, for instance, in this question, it's the nearest hundredth. The moment you see that, you should always have two places after the decimal point, including putting a 0. So if it's something like 0.8 instead of 0.88, then you should always put 0.80. And here's example 1. Express each ratio as a fraction and as a decimal point to the nearest hundredth. So let's take question number 1. Sine is sine of A. So sine is equal to opposite over the hypotenuse, and I've abbreviated it here. What's opposite A? Well, this is angle A, so what is opposite? It's going to be 16, and the hypotenuse is going to be 20. And just like you know, simplify your answers. So it'll be 4/5. Okay, and then 4/5 will be 0.80, because the question, like I said, nearest hundredth. If you put 0.8, you actually haven't answered the question that it's asked for, so you won't get the point. And using trigonometry, using special right triangles, this is a 30, 60, 90. And don't forget, if the smallest side is opposite the shortest angle, so the shorter leg. Okay, this is the longer leg and this is the hypotenuse. Putting things together, all right, it's talking about the tangent of it. So the tangent is opposite over the adjacent. Quote the formula. Put in what you've been given. Well, opposite it is x. Adjacent to it is x root 3, which is given to you here and here. Okay, and then don't forget, you cannot have a radical at the bottom of a fraction, your denominator part. So simplifying it by multiplying it across, and then simplifying it down as much as possible. Okay, in this case it's simplified down to root 3 over 3, which is 0.58 on your calculator. And again, it's to the nearest hundredth. So don't round up to 0.6, you're getting it wrong. Okay, question number 7. Special right triangles to express 60 degrees as a fraction and as a decimal to the nearest hundredth. Well, if you look at it, it doesn't look as if you've got any information. So Is it as difficult as it seems? Well, let's have a look. Best thing, you know me, draw your little triangle. Same one as they drew in the example. Okay, here's your right angle. This guy will be 60 degrees. And this guy here will be 30 degrees. We don't know any information, so let's start using X. So opposite the smallest angle is the shorter leg, which is, we'll claim that as X. The link between the shorter leg and the longer leg, which is opposite the 60 degrees, is you multiply it by √3. So this is going to be X √3. And the link between the shorter leg and the hypotenuse is twice the shorter leg, so that's going to give you 2x. All right, now we've got a bit of information. Let's put it into the expression that they want. They want sine 60. Well, sine is equal to opposite over the hypotenuse. That's your basic formula, simplified down. Okay, we want the 60 degrees, so there's our target angle. Opposite 60 degrees is going to be X √3, and the hypotenuse is 2x. Okay, still looks a little bit complicated, but then you can cancel the x out, and what have you got? √3 over 2. So we've got √3 over 2, and that's in its fraction form. And as a decimal, using your calculator, and again to the nearest hundredth. Well, on a calculator it's 0.866, so let's round it out to 0.87. And here's an example of the type of thing you're going to be doing. Okay, as you know, with your shadows, you use your height against something and rearranged it. Here you're going to mark the distance, which in this case is 100 feet. You will be able to find the angle. We will measure the angle. So from that you can find the height of the building and how far diagonally would it be to the top of the building from where you're standing. Okay, so for each question you've got to make a decision. Is it sine, cos or tan? Well, as you know, what is going to make the difference is your target angle. In this case, your target angle is 52. Okay, so now you've got to name the side. So let's have a look at this question number 8. This side is opposite. It's opposite the angle. This side here you've been given is the adjacent. Okay, then looking at SOHCAHTOA, the only one that doesn't use the hypotenuse is tan. So it's tan equals opposite over the adjacent. Okay, put information that you've got. So tan 52 is going to equal x over 13. Rearranging it, you will have x equals tan 52 times by 13. And again, it's a calculator situation, so you can plug it into your calculator. But again, check it, it's to the nearest hundredth again, and it's going to be 16.64. So again, make sure you answer the question to the degree of accuracy 100th. And here's where you've been given the sides, you've got to find the angle. All right, so now we're doing the inverse of trigonometric ratios. Okay, you're still using SOHCAHTOA, but get used to when you're looking at an angle, writing -1 next to it. It means in mathematic terms the inverse of whatever it is. Okay, you quote the formula, all right, and then plug in your numbers. You don't have to simplify it because your calculator will do 18 over 27 anyway. If you want to cancel it down, it's entirely up to you, but you know me, the more math you do, the more chances you've got of making a mistake. So just put sine inverse -1 of 18 over 27 and it will come up with your answer. Okay, there's your answer that will be on a calculator, but again, make sure you read the question. This is the first time now we've come to the nearest tenth, so simplifying our answer to the nearest tenth is 41.8. Don't round it up again to 42. 41.8 is already been rounded up. So here's where trigonometry becomes again a bit tricky. We're looking at angle Z. Angle Z is your target angle. And again, we need it to the nearest tenth. But let's go back to angle Z. Let's label the sides. This guy here is opposite. This guy here is the hypotenuse. So which one uses opposite and hypotenuse? It's a sine question. So again, so write it with the inverse in. Sine -1, opposite over the hypotenuse. Quote the formula. Okay, substitute in. Opposite is 5, so 5 over 9. So you want sine -1 of 5 over 9. And that will give you, to the nearest tenth, 33.7. So make sure again, your answer reflects the question, the nearest tenth. And here's a typical type of SAT, ACT question. It's asking you to solve the right triangle, right round side measures to the nearest tenth and angle measures to the nearest degree. In other words, you've got to find the two missing angles and the missing side. Okay, and it's entirely up to you where you start. It doesn't matter, but in the example they've started with X. And again, label what you've been given. This is opposite, this is adjacent, and like it's got here, it's a tangent question. Okay, we're finding the angle, you find the inverse of the angle, and eventually you'll get to 61. All right, and that's to the nearest degree. It's a whole number, so make sure that, again, you don't have any decimals. Okay, so now we know that angle X is 61 degrees. You know that angle Z is 90, so X and Y must equal 90. And then it's just a case of subtracting, so 29 degrees. So now we know our two angles, okay? And at this point now, to find the XY, yes, you can use trigonometry, but the only way you can use trigonometry is to use one of your two answers. Well, just in case you've made a mistake, don't use your answers. Okay, it's as simple as that. So if you look at what they've done in step 3, they've used Pythagoras. Okay, so Pythagoras links in with trigonometry. So to find the third side of a right-angled triangle, and you've been given two sides, always use Pythagoras, don't use trigonometry. Okay, and then again, you will see that you've got your answer, that you've got for your hypotenuse. Again, you've got that little bit of a check. If your hypotenuse, which in this case is slightly over 10, if it's smaller than the 9 or the 5, you know you've made a mistake with the calculations, all right? So always check your work. All right, number 15, solving right triangle, round your side measures to the nearest tenth, angle measures to the nearest degree. We're going to do angle measures to start off with, and it doesn't matter which one you pick, R or T. One's going to be a sine question, one's going to be a cosine question. It's up to you, but I'm just going to pick angle R. So I'm going to start with angle R. I'm going to label the sides. So this guy is opposite, and here is your hypotenuse, so it's the sine question. Quote the formula, sine -1 equals opposite over the hypotenuse. Substitute in is 6 over 9, which will give you 41.8, but in this case 42, because the question asks to the nearest degree. Okay, so if angle R is 42, then angle T must be 90 subtract the 42, which is going to give us 48 degrees. And if you want to spend a few seconds just adding together 42 and 48, you'll realise you've got your 90 degrees. Okay, so there's the angles. Now we need to use the trigonometry to find the missing side. Okay, so Pythagoras. So Pythagoras, a squared plus b squared equals c squared is your formula. Okay, well, we've been given the c squared, that's 9, so that's going to be 9 squared, and that's going to, I'm going to count a as 6, so that's 6 squared plus b squared. So rearranging it, b squared is going to equal your 9 squared minus your 6 squared. So b will be the square root of that. So b is going to be 81 subtract 36. And square root your answer, and you will finish up with, to the nearest tenth, 6.7. And here's your check. Okay. T is bigger than R, so that's R is your smallest angle, T is your middle angle, obviously S is the right angle. So obviously your answer needs to be somewhere between 6 and 9. Well, we've got 6.7, so just you doing a basic check, we can prove